Today, I'm joined by Dr. Paul Young, who is at Lancaster University. You're atmospheric scientist, is that correct?
Yep, that's right.
What is that?
So I study anything to do with the atmosphere. I'm actually originally a chemist. I did a degree in chemistry, and then I got really interested in climate science and how everything is all connected. And anyway, the atmosphere is the receptacle for a great many things: pollution from us, from energy from the sun, the weather, the climate, and things like that. So I study, yeah, the climate, the air pollution and the ozone layer, and all of those things. So anything that's in the atmosphere is fair game.
So, you have studied specifically about how sort of human activity has affected the atmosphere. Is that correct? How could
Yeah.
you describe that to us just in a soundbite for us? Quick chunk.
Okay.
It's a big topic, isn't it?
It's a huge topic. Human activities affected the atmosphere. Well, some would argue that goes back to ever since there have been humans, ever since we were lighting fires. But all the stuff that we do, the things we do, cars that we drive, the factories that we run, the forests that we grow, the farms that we have, all change the atmosphere. They can sometimes put various chemicals up in the atmosphere. They can also change the way that the atmosphere flows if we're talking about big things that we've done. But I'm mainly interested in pollution that comes from human activities. And really that has been most important since what we call the pre-industrial times. So for us, that's basically anything around the Industrial Revolution, 1750 onwards. We're interested in carbon dioxide, which I'm sure listeners are familiar with, but also things like nitrogen oxides and volatile organic compounds, which you may be less familiar with, but these are very reactive things which can come out from cars and from factories, and even from plants as well, actually.
So this is an environmental show talking about all the different things that are happening in the headlines and the different sort of initiatives that governments and businesses are doing. But there is a big question for a lot of people, and you coming from your background, your research, and the people that you've worked with yourself, and you're talking to someone who maybe feels a bit skeptical about what they're seeing and hearing. They're not really sure what the right sources are. How do you find a meeting ground with that person to go forward and talk about all these things, and particularly talking about sort of changes that we're expected to make?
That's a really hard question. I think first and foremost, I like to try and be a human to this other person. I think to realize that we may have different priorities, might have different values even. And I think it's, you need to have a conversation with that person to find out what it is that they're interested in, or what they hold dear. So, this is a very kind of high level thing, but I think that's how I like to go for it. So, for instance, someone might be really skeptical of climate change because they might think that it's a way of imposing a particular set of rules or values or laws or something like that from someone who they don't agree with. And I think so often, even before I would get to the science, I would like to reassure them that the science, as I would hope to convince them, is really solid. The evidence is really good. But it doesn't mean that we have to act in a certain way. There are lots of solutions that people could come up with, and I might have something that I think would be a good idea to do, but someone else whose values, whose background, or even where they live is different to me might come up with something else, some other way that they'd like to address this problem. I think we still need to address the problem, but I think that there are many different ways of doing it. So I think initially I'd like to have that kind of conversation, really, is to say, let's not make this about the science. That's happening. Climate change is definitely happening, but it doesn't mean that it's a fait accompli for a certain type of solutions, which they may or may not like. And then, sorry.
Well, I want to talk about that sort of those options and opportunities that you're talking about of maybe having different ways of going at this problem. So we're going to listen to some music. We're going to be back because I want to hear sort of see what you have to say about some of the things that have come out of COP26 and the solutions that have been offered already. So thank you so much. We'll be back in just a minute. I've been speaking with Dr. Paul Young, who is a lecturer at Lancaster University specializing in atmospheric science. And I wanted to talk to you about sort of, we'd said earlier in the show about ways of addressing this problem, saying this is the problem and these are the different ways that we can do it. And one of the, for me as an individual, I feel a lot of pressure. I feel like if it goes wrong, it's because I haven't done something right, or the government's asking me to do things that I can't do. I can't necessarily put solar panels on my roof. So where do you think that balance is between private business, government, and then individual responsibilities?
This is a really good question, and it's not one that I'll have a magic bullet for to answer. But I think you're absolutely right to kind of point at this idea of balance. And I think often there is an emphasis on we'll call behavior change. You know, the individual. Well, if you don't want to get ill through breathing in poor air, so if we're now talking about air pollution, then take a different route to school, rather than actually clearing up the air pollution on the road, which would be what we call like a system change, changing the problem itself. So changing rules, moving the road, changing the what cars and what buses and what lorries can do and emit. And we can look at this for air pollution. We can also look at this for climate change. I mean, personally, if I'm allowed to be personal, I am a human, I'm a scientist. I think that quite often the balance is a little bit too much to this sort of individual change, individual responsibility. I think that's absolutely has to be part of it, but changes at the system level are really going to be the only way that we're ever going to reach net zero or clean up our air and deal with air pollution.
Do you think that net zero is actually attainable? If as things are going as they are, and sort of looking ahead, obviously we don't have our magic 8 balls, crystal balls, but could we do that? Do you think that we can actually do that as a nation, as Earth, globally?
That again, you've got these $64,000 questions here. Do I think that's
no pressure?
I'm not a I'm not a technologist, right? I'm not an engineer. I'm a scientist who studies the effect on the atmosphere. So I have no special insight into like, you know, what technologies there might be coming on stream. I can say, and I think this is true of a lot of climate scientists. We can see that there's the scenarios that talk about net future. So these sort of future storylines that sort of get us to net zero. They do depend on technologies which do not exist at all at scale yet. So, you know, it's very hard to put a lot of truck in those scenarios because they're based on sort of, well, what some people would euphemistically call technological unicorns.
It's very aspirational, maybe. This is what we'd like.
Aspirational is a glass half full way of putting it, for sure. I think, you know, I get that's it. You know, some days I wake up and I think, yeah, you know, human ingenuity, absolutely. We'll get there. There's this problem it's hugely urgent. We're going to have to deal with it. We compare it to the ozone layer issue, for instance, which some of your listeners might be familiar with. Basically, in short, there were a bunch of gases that we were using in aerosol cans, that we're using in our fridges, and it turned out these were damaging the ozone layer. And very long story short, we replaced those gases. We were able to engineer new gases which didn't destroy the ozone layer. Now, climate change is a lot more complicated a problem than dealing with the ozone layer, because that was just dealing with these handful of gases and a handful of uses. But, you know, that was an example of human ingenuity, environmental urgency, and coming together to solve a problem. So, okay, you know, that's my glass half full way.
I was a 90s kid, which meant when I was in school, it was like the whole new ozone layer. You heard about it all the time, and you heard about CFCs, and, you know, your hairspray was destroying the ozone layer and things like that. And then it just stopped being talked about. And now I understand why. This was a problem that people who had influence and expertise came together, and I don't know if you'd say they solved it, but they addressed the problem in a way that's made our environment better.
Absolutely. There's a whole lot of nuance to that story. And should anyone listening want to come and hear more about the ozone layer, then they can come and do a degree and be taught by me, and they'll get a lot about it. But yeah, I mean, the bottom line is that, you know, that was something that was addressed. We looked at acid rain actually as another example. For instance, factories in the US leading to acid rain happening in Canada and destroying the forests,
Yep.
but also in the UK and destroying forests in Scandinavia. And laws were enacted, scrubbers were put on power plants, and that issue was addressed. So, you know, there are, I don't want to say just because we've solved that means we can solve climate change, but I think personally, I don't want to get too doomerist about it. I think that these stories are important, I think, to hold on to.
I find that really fascinating because, like I said, I didn't think about it till you just said it. But yeah, that's a story that I grew up with. I do want to, in a bit, after some music and a bit of a break, I want to talk about those sort of big picture ideas and think about sort of our place in the UK, in Furness, our place within that sort of global picture. So we will be back in just a moment. I've been speaking with Dr. Paul Young from Lancaster University, and one of the reasons why it was important for me to talk with you is because when I see those big headlines, and there's a different one on every paper, and you don't really know who to trust and where their science is coming from. I can't go and read all the literature, all of the articles and papers and speeches regarding the complexity of when we're talking about climate change. So it's hard to know who to talk to. So thank you so much for your time. But one of the big questions, though, is that we can have the best will in the world. Here in the UK, we can get rid of our coal power plants. We can install more charging points for electric cars. We can do all these things. But if other industrialized nations aren't doing that, does it make a difference? Is it going to be, are we going to go through a lot of expense and changes are hard, for something that might not have a global significance?
Yeah, it's interesting. I think there's one sort of trite answer is that a lot of people talk about global Britain, the global Britain that's so big and wants to do everything and be a success, and then there's the global Britain who's too small to do anything, and it's kind of, I don't know which one do we want to be. So I think, I mean, so to seriously answer your question, there are a couple of other countries in the world, so China and the US and Russia, whose amount of CO2, actually a few others as well, but I'm sorry to name those, but whose amount.
I won't take it personally.
No, it's okay. sorry. So whose emissions are very large, and they do make up a really big proportion. So we do need to see some action from them for sure. But then there's a whole bunch of countries that are like us, which are, you know, adding just a small amount. And so individually they might not look like it's making a huge dent in something, but it's these bunch of countries who've got the small amount who will add up to make a large amount of reductions if they all go to net zero, for instance. I think there's the other issue is actually the amount of climate change that we're experiencing. So we talk about global mean temperature change, and your listeners have probably heard of these numbers: 1.5 degrees, 2 degrees warming, which don't sound very big, and maybe we can talk about that again in a minute. But those numbers are actually related to the total amount of carbon dioxide that's gone into the atmosphere since year dot. So we, as Great Britain, who have been, we were one of the very first countries to industrialize. We're not very far, 40, 50 miles away from the seat of the Industrial Revolution in Manchester. You know, we've been emitting a lot of carbon dioxide, a lot of CO2, and actually of the total amount of CO2 that's ever been emitted, we're about 5%, I believe. So if you look at like what we are responsible for in terms of the climate change, we do become more significant. So there are issues of equity and justice. You know, we cause a pretty good chunk of this change which has happened, and some of which will continue to happen. And we need to take action on it. I believe we need to take responsibility for that.
I do want to talk about that responsibility in a little bit, and also those degrees, because I think that for someone who isn't sort of up on the latest science, it's hard to know what that means, 1.5 to 3 degrees. So we're going to take a break and we'll come back and talk a little bit more about the actual science bit of climate change. I've been talking about climate change with Dr. Paul Young from Lancaster University, who is an atmospheric scientist. And the number that has come up over and over again in the last few weeks, and you brought it up in the last segment, was 1.5 degrees. All right. I still struggle going back and forth between Fahrenheit and Celsius, and I'm still getting used to the British climate. So 1.5 degrees Celsius, what sort of change is that actually going to be?
Yeah, it's good because it's one number for the whole world. I mean, one way you could think about these numbers is that they represent essentially an extra amount of energy that we're keeping within what we call the Earth system, within the atmosphere, within the oceans, and everything. So as that number gets bigger, we're trapping more energy. So this number, so 1.5 degrees, is an average changeover everywhere. And if we zoom in, well, let's think about something else. So we've warmed now 1 degree, and that's 1 degree since sort of 1850, 1900. We've warmed 1 degree as a world, but that's not the same everywhere. The land has warmed more than the oceans, because land just heats up more quickly than water. And then we looked at other places like the Arctic, and there's a whole bunch of processes that are going on there, which I'm not going to go into, but the bottom line means that has warmed about 3 times faster than the rest of the world. So you're talking 2.5, 3 degrees warming up in the Arctic, which means reduced sea ice, but also changes in weather, and even the jet stream, which affects our weather here in northwest England, can all be connected to changes in there. So yeah, this 1.5 degrees number, or 2 degrees, or 3 degrees, this extra energy, and it doesn't mean that everywhere's going to change by that amount. It doesn't mean that everywhere's going to change by that amount at the same time. But the bigger that number, the more the impacts, the more heat waves there are, the more sea level rise there is, the more droughts there could be, the more intense storms there could be.
I think that's one of the things that I think is not necessarily confusing, but for so long it was just global warming. But this change is supposedly behind a lot of the extreme weather we've been having recently. Are we actually seeing those effects now with extreme weather?
Yeah, we are. This is a really quite a new area of atmospheric science research, of climate research, what they call real-time attribution. And what that means is that they can look at a particular extreme event and say, this event has happened. Could that event have happened if we hadn't put all of our greenhouse gases in the atmosphere? Or you could phrase the question like, how likely would that be if we didn't have all these greenhouse gases in the atmosphere? So a really extreme one from perhaps close to your country. Think that there was a very strong heat wave over the summer in northwest USA and Canada, called the heat dome, where were insanely high temperatures of like reaching 50 degrees Celsius, and that's an awful lot Fahrenheit. And some people, some scientists have looked into this, and the bottom line is they found that is virtually impossible for that event to have happened if we hadn't been putting all these greenhouse gases up in the atmosphere. In its,
I was going to say, but within the same year, though, you had this bizarre cold snap in Texas, where they had well below freezing temperatures for a long time, and they weren't equipped to deal with it. So that those two extremes in two very different places in the United States this extreme heat and this extreme cold can they be the same related to climate change?
They can be. I can't speak particularly to that event in Texas. It's not something that I know about. But if we think about, okay, maybe here's one example that that sort of from where we are. So we have something called the jet stream. Again, your listeners may be familiar with this. And this is a very fast band of winds. And if you watch the weather forecast, and a lot of meteorologists talk about this, and if that jet stream is above us in the UK, if it's sort of to the north of us, then we get warmer air coming up, and so we're a bit warmer. And if that jet stream is to the south of us, we get colder air. We get cold air from the pole. So it's like a barrier between the warm and the cold air. Now that moves around, year to year, even week to week. That's how we see this variation in temperature that we're having. But what might happen is that climate change might change the amount of time maybe that fluctuates between the being warm and being cold. So it might put that jet stream in a position where it is going more to the south of us. And so we could experience colder weather, more of that polar air. On the contrary, we may see it go to the north of us as well. I've very simplified that, but that's one of the ways in which the climate change can manifest itself in perhaps ways that we might not expect, like these sort of cold weather, as opposed to being warm all the time, as you discussed.
Okay, so you reminded me of my favorite disaster movie ever. So I'm going to ask you about that and the science in just a bit. So we've been talking about climate change and the atmosphere with Dr. Paul Young from Lancaster University. And I have to ask you, I'm a little bit afraid because my absolute favorite disaster movie is The Day After Tomorrow. If any of my listeners haven't watched it, please do, just to enjoy the sort of over-the-topness of it. But essentially, it's about I believe he's a climate scientist as well, but he studies sort of long-term sort of I've lost the word in my head, but projections of what may happen if this happens. And it's supposed to be on like a 500-year plan, but it's actually only 3 weeks, and all the chaos that ensues from that. And I think what you're going to tell me is that the science is absolutely perfect. They got it right. This is exactly what's going to happen. And it's going to be next week. And Dennis Quaid is going to be coming through on a snowmobile, right?
I'm extremely sad to disappoint you. This is one of the favorite ones of atmospheric scientists to debunk this movie. So it was lovely to see. I think it was the first time that we saw climate change in a movie, and I think as climate scientists, we were very impressed to see that he ran a climate model in a really short time, something that would take us months to program. He turned around in a day. So all those things were very, very lovely, and it's very flattering, to have your profession on film. But yes, in that movie, I'm afraid the science doesn't quite stack up. So what happens, as you know, there is a big freezing event, and the way that they describe it is there are these big storms, and they pull down air from the stratosphere, which is the atmosphere about 15, 20 miles above us, where the air is very cold, and it sucks down that cold air and leads to a massive big freeze. Now, actually, what would happen is if you were to bring air from up in the stratosphere down as quickly as they do in the movie, it would heat. It would heat to over 100 degrees Celsius, probably even a bit more, because as you're bringing that air down, it's getting compressed. And you can think about this like a bike pump. So if you were pumping your tire, if you've ever put your thumb or something over the end of the pump, you'll feel it's warm, sometimes very, very hot, and it will burn you. And that's because you're compressing the air. And as you compress air, you heat it. And yeah, this is what happens. So if we've gone from the stratosphere down to the surface, I'm afraid it would lead to heating rather than cooling. I will say, if I may, there is we could have a situation like this, and this is what might happen. I mentioned about the jet stream earlier, and some of your listeners may have heard of the Gulf Stream, which is something that runs in the ocean, and that's why we in the UK are a little bit warmer than people at the same latitude than us over in Canada. And one of the things that might happen on very long-term climate change is that circulation can get shut down. The heat doesn't get brought to us, and we in Europe get very cold. And again, that's something that's maybe of a bit more likely scenario, but I'm afraid it doesn't happen instantaneously as it does in the movie.
I actually just realized now, because you have these forums of people who are really into Lord of the Rings or really into Marvel, and they just type furiously arguing about this stuff. There are forums for scientists just to talk about how terrible the science is in this movie, isn't there?
Twitter, we call it Twitter, yeah.
Now I know what to look for. Do you have a favorite environmental disaster movie? There've been some pretty amazing ones in the last few years.
I think you're funny enough. That movie, The Day After Tomorrow, even though I've just completely debunked it, it was the first environmental disaster movie I saw. I think it just about came out as I was doing my PhD, and I think just despite all the science, I was extremely excited to see my science area on the big screen. So everyone can like that. So I like it for that reason.
Thank you so much for being on the show. I feel like I've learned a lot, but mostly I have lots and lots of more questions. So hopefully you'll be back on to help us sift through all the information. Thank you so much, Paul.
Thank you so much for your time too. Really enjoyed it.